Hello, Mario. Engineering Surveying Worksheet 002. I've been asked to have a look at this worksheet and give a bit of an explanation around it. So let's get the worksheet front and center. Here it is here. And probably need to get it up there so that we can get it full screen. Worksheet 002. So, bit of a classic survey problem, really. Given that the instrument is set up over a mark P, which is down here, RL 105.07, and it's 1.55 meters to the transit axis, so that's the height of the instrument. Calculate the grade between A and B. If V1, which is a vertical angle, is 10, 10, 30, V2, 15, 42, 15, and the slope distances, SD, P to A, have been measured as such there, and the angle APB, 110, 12, 30, and the height of the target, or HR, in each instance, or the prism, 1.8 meters. So the first thing we need to realize is that the angle, the horizontal angles, will be measured in a horizontal plane, and the slope distances. So we need to get everything reduced down to a horizontal plane. So the first thing we've got to do is to in these triangles here. So this first triangle here is the triangle PCA. That's in the vertical. It's a vertical angle, so it's in the vertical plane, if you like. And we need to reduce that slope distance of 110.25 down to the horizontal. So that's quite simply using SOHCAHTOA or what have you. We're actually going to need the difference in height as well, so we may as well do it at the same time. So if we go sine 10 degrees, 10 minutes 30, opposite over the hypotenuse, that will give us 19.476. So that's sine 10 degrees, 10 minutes 30, 19.476. Cosine of 10 degrees, 10 minutes 30 times 110.25 will give us 108.516. Just note that obviously the slope distance, or the hypotenuse, is always the longest side in the triangle, and so that looks about right. Now the same thing happens in the second triangle, where we have a different slope distance, different angle, but we can work out the difference in height and the horizontal distance. So that's all well and good. Now that we have a horizontal distance, and we've got our two, we can look down from in plan view at the horizontal or the horizontal triangle, which is PCD, A or PAD. It doesn't really matter, because A is vertically above C and B is vertically above D, like so. So we can look at that triangle here, and I've done that down here with the horizontal distances. So we've got 108.516 here and 134.764 here, and the angle between them, as stated, is 110.12.30. So there we are, we have a triangle, and we can solve that triangle using the cosine rule. A squared equals B squared plus C squared minus 2BC cosine A. So filling in the various things, remember that it's this side here, it's the two sides, the square of the two sides minus 2BC, which is the 2 times the sum of the product of the two sides times the cosine of the angle between them. So we can pretty easily fill in the gaps. It's just the values that we've got, and that will give us a squared. We take the square root of that, and that should give us a, which is written there as 200.101. 200.101. But then it's also written in there as 99.851, so I don't quite know what exactly is going in there. I think I have possibly not updated the 200.101. Looks like it's been fixed up, and I've omitted to fix the 199.851 on the diagram there. So now that we have got the distance, which I'm going to take as 200.101, we need to work out the grade. Now, to work out the grade, we're going to work out the RL of each of the points. So the RL of A, which is the RL of A is 105.07. So starting here, 105.07, add the height of instrument, which is 1.55, and then to go to A, we could add the difference in height, which is 19.476. That's going to take us up to the prism, and then we subtract the 1.8, which is give us 124.296. So just take that again. The RL, or the height above sea level of A, down here at the ground. Then we go up to the instrument height, and we can go along horizontal up to the top of the prism, and then back down to A. And similarly at B, we start at 105.07 up to P here, and then that's horizontal there, no change in height, up to B, which would be the 37.891, and then drop down the minus 1.8, 142.771. All right, so we've got 142.771. So what we've been asked is to calculate the grade between A and B. Alrighty, so here we are, the grade, or the grade as a percentage, equals rise over run. So we've got 142.711 is the height at B, and if we take away from that the height at A, 124.296, and then divide that by 200.101 and multiply by 100%, you'll get 9.203%. 9.203%. Okay, 9.203%. That can also be expressed as a representative fraction. It's just a matter of reversing it. So it'll be 200.101 divided by the top there without the percentage sign, or you can go 1 over 9.203. 1 over that should give you 10 with the percentage thing there. So yes, 200.101 divided by the difference should give you 10.866, which gives you a 1 to 10.866. If you wanted to work it out from the percentage, of course, it's 100 divided by 9.203, which should give you 10.866. So please disregard this little here. It seems to be an uncorrected error that has resulted, and that's sort of could possibly be deleted. But apart from that, everything's pretty good, and that's how you work out worksheet 2. Cheers! See you!